How do video games build such realistic worlds? It all comes down to one powerful idea, the vector.
Whoa, that's a bold statement. It kind of suggests that jumping straight to numbers misses something really important.
So what is a vector really? Well, you can think of it in two ways, as an arrow or as a list of numbers. So how can an arrow and a list of numbers be the same thing? The secret is a common language.
Think of it like putting a pin on a map. We just anchor the vector's tail right at the origin.
And this is where the magic happens. The numbers aren't just labels, they're actually instructions for how to move.
Yeah, it's like a little treasure map. The first number is how far to go sideways, the second is up or down.
Okay, time for a quick quiz. If you follow these directions, which vector do you actually get?
All right, so we get single vectors, but what happens when we start combining them?
So picture taking one step, then another. The sum is just the shortcut from your start to your final stop.
It's kind of like adding on a number line, but now you have the freedom to move anywhere.
And this is where the numbers are just awesome. Forget drawing arrows. The math is way easier.
Seriously, it's so simple. Just add the corresponding numbers together, and that's it. You get the new vector.
All right, let's test that out. If you add these two vectors, what's your final destination?
Okay, we can add vectors, but what if we just want to change its size? That's where scaling comes in.
Think of your vector like a rubber band. If you multiply by 2, you just stretch it to be twice as long.
And if you multiply by a fraction, like 1/3, you just squish it down to 1/3 of its size.
But a negative number does something cool. It completely flips the vector's direction and then resizes it.
So these numbers that stretch, squish, and flip vectors, they've got a special name. We call them scalars.
And guess what? The math is super easy again. You just multiply each number inside the vector by that scalar.
Okay, one more quick check. What do you get if you scale this vector by 1/3?
So, what's the big takeaway here? It's being able to jump between the visual arrow and the list of numbers.
And this isn't just theory. It's the language behind data science, physics engines, even computer graphics.
So, we've covered the basics, but with these tools, just imagine what else we can build, right?